Hello everyone, you are on the channel Who Created It and How? Today we're looking up, way up, at one of the most breathtaking architectural features ever conceived, the dome. From ancient temples to modern stadiums, these colossal curved ceilings have captivated us for centuries. But have you ever stopped to wonder, how on earth did they build these things? How did ancient engineers, without modern cranes or computer models, manage to create such massive self-supporting structures that have stood the test of time? Well, get ready to have your mind blown, because today we're diving deep into the genius engineering behind the construction of domes. Let's start with the basics. What exactly is a dome? In simple terms, it's a hollow, hemispherical structure. Think of an arch, and now imagine spinning that arch 360 degrees around its center. That's a dome. This shape is incredibly strong. The secret lies in how it handles weight. The force of gravity, called compressive stress, pushes down on the top of the dome. But instead of collapsing, the dome's curved shape channels this force downwards and outwards along its curve and into the supporting walls or pillars below. This brilliant distribution of weight is what allows domes to span huge spaces without needing any internal columns. It's pure structural poetry. Now let's travel back in time. The earliest domes weren't quite the smooth soaring structures we think of today. They were built using a technique called corbelling. Imagine stacking rings of stones, one on top of the other. With each new ring, the builders would cantilever it or project it slightly further inward than the one below it. They continued this process, layer by layer, until the rings met at the top, leaving a small opening that could be capped with a single stone. The famous treasury of Atreus in Mycenae, Greece, built around 1250 BC, is a prime example of a corbel dome. It's an incredible feat of early engineering, but it has its limits. The inward slant of the stones creates a lot of tension, meaning corbel domes can't be too wide or they risk collapsing. The real game changer came with the Romans. They were the masters of concrete and the true arch. By combining these two innovations, they revolutionized dome construction. The Roman recipe for concrete was a mix of lime, volcanic ash called pozzolana, and chunks of rock. This stuff was a miracle material. It was strong, versatile, and could even set underwater. With this concrete, they could create what we call a true dome. So how did they do it? The key was a massive temporary wooden framework called centering. Imagine a huge, precisely shaped wooden skeleton in the exact shape of the final dome. This framework would support the dome as it was being built. Workers would then pour their concrete mixture over this wooden form, often embedding stones or bricks into it for extra strength and to save on material. Once the concrete had cured and hardened completely, a process that could take weeks or even months, the nerve-wracking moment arrived. Workers would carefully dismantle the wooden centering from the inside. If their calculations and construction were perfect, the dome would hold its own weight, a massive monolithic shell of solid stone. The Pantheon in Rome is the ultimate testament to this technique. Its 142-foot diameter concrete dome, completed around 126 AD, is still the largest unreinforced concrete dome in the world. It's an absolute masterpiece. The Romans also used clever tricks to make their domes lighter. As they built the Pantheon's dome upwards, they gradually changed the aggregate in their concrete mix. At the base, they used heavy travertine rock. Higher up, they switched to lighter tufa and pumice stone. This reduced the overall weight and stress on the structure. They also included recessed panels, called coffers, on the interior surface. These not only looked beautiful but also removed a significant amount of weight without compromising the dome's structural integrity. And that famous opening at the top, the oculus? It wasn't just for letting in light. It also removed the need for the heaviest, most difficult to place part of the dome, right at the apex where the compressive forces are greatest. Sheer genius. Fast forward to the Renaissance, and we arrive at another legendary dome, the dome of the Florence Cathedral, designed by Filippo Brunelleschi. The challenge here was immense. The opening for the dome was over 140 feet wide, and the city fathers of Florence had forbidden the use of traditional wooden centering from the ground up, as it would require a whole forest of timber and halt all activity within the cathedral. So Brunelleschi had to invent a completely new way to build. His solution was nothing short of revolutionary. He designed a double-shelled dome, an inner dome and an outer one, connected by a series of massive stone and wood ribs. This made the structure lighter and more stable. But the real magic was in how he built it without full centering. He devised a system of cantilevered scaffolding that was built up from the dome itself as it grew. And to counteract the outward pressure, or hoop stress, that wanted to push the walls apart, he encircled the dome with huge sandstone and wood chains like invisible belts embedded within the masonry at various heights. Even more incredible was his bricklaying pattern. He used a self-reinforcing herringbone pattern, where bricks were laid vertically at certain intervals. This locked the horizontal courses of bricks in place and created a stable, spiraling structure that could support itself as it was being constructed. It was a slow, painstaking process that took 16 years, but the result was the largest masonry dome in the world, an icon of the Renaissance, built using methods that were centuries ahead of their time. From the Renaissance onwards, dome construction continued to evolve. We see beautiful onion domes in Russia, often built on lightweight wooden frames. In the Islamic world, architects perfected intricate muqarnas, decorative vaulted ceilings that look like honeycombs, and used complex geometric patterns to create stunning double domes. Sir Christopher Wren, designing St. Paul's Cathedral in London, took inspiration from Brunelleschi and the Romans. He built a triple dome structure, a shallow inner dome for a pleasing interior view, a hidden brick cone in the middle that provided structural support for the heavy lantern on top, and a lightweight outer dome covered in lead to create the magnificent external skyline. Then came the Industrial Revolution, and with it, new materials that opened up a whole new world of possibilities. Iron, steel, and reinforced concrete changed everything. These materials had incredible tensile strength, meaning they could handle being pulled and stretched, something that stone and brick can't do very well. This allowed for domes that were lighter, wider, and more daring than ever before. Joseph Paxton's Crystal Palace in 1851, though not a traditional dome, showed what was possible with cast iron and glass creating vast light-filled spaces. In the 20th and 21st centuries, we see the rise of geodesic domes, popularized by Buckminster Fuller. These are sphere-like structures made from a complex network of interconnected triangles. The triangular framework distributes stress across the entire structure, making them incredibly strong and lightweight for their size. This design allows for the rapid construction of large enclosures using minimal materials. You've probably seen them at places like Epcot Center or in botanical gardens. Modern sports stadiums and arenas also often feature domes, but these are typically built with massive steel truss systems, prefabricated on the ground, and then lifted into place by gigantic cranes. Advanced Computer-Aided Design, or CAD, allows architects and engineers to model and stress test these incredibly complex structures before a single piece of steel is cut. So from the simple stacked stones of corbelled vaults to the concrete marvels of Rome, from Brunelleschi's ingenious brickwork to the steel and glass wonders of today, the story of the dome is a story of human ingenuity. It's a tale of pushing the limits of materials and imagination. The next time you stand beneath one of these magnificent structures, take a moment to look up and appreciate the incredible journey of engineering that made it all possible. Thanks for joining us on Who Created It and How. If you enjoyed this journey into architectural history, don't forget to like, subscribe, and hit that notification bell so you don't miss our next deep dive. See you next time.